Hey, Mr. Harrodom here. We're going to do what is a mole for elements. Okay, a mole is just a number. Okay, just like a dozen means 12, a mole represents 6.022 times 10 to the 23rd atoms for a pure element. We call this Avogadro's number. Okay, so we are going to know that one mole represents 6.022 times 10 to the 23rd atoms for any element. Okay? The atomic mass of an element represents the let's go with molar mass of no, I just don't want molar mass. Nope. Sorry. The mass of grams in 1 mole of pure element. No, I do want molar mass. Because molar mass is defined as the mass of 1 mole of substance. Now remember, substance could be either elements or compounds. I'm just talking about elements right now. Okay? Elements, atomic masses are usually recorded to the hundredth place. You look them up on the periodic table here. That's why you get a periodic table to look these things up. Okay? And they are always labeled with the units G/mole. Down with the gangsters. Grams per 1 mole. Okay? I use MOL to abbreviate for moles. Okay? It is the mass of 1 mole, or 6.022 times 10 to the 23rd atoms of a substance. Okay? So 211 here. Let's look up at some atomic masses here. Okay? If you're trying to figure out where I'm getting these, I'm getting these from the periodic table here. So for instance, xenon. Xenon says 131.29. So I'm going to write down 131.29 G/mole. Okay? Boron. Atomic mass is listed here. 10.81 grams per mole. Down with the gangsters. We know that gold is AU. Hey, you know what silver said to gold? AU. Anyways, 196.97 G/mole. Arsenic, we know is AS, 74.92 G/mole. Down with the gangsters. You know. Magnesium, Mg, 24.30 G/mole. And then tungsten, my favorite element of them all, one of them, 183.85. If you notice that this periodic table doesn't have the names of some of the elements on there, those were the ones you were supposed to memorize. That's why they're not there. Yeah, greatness, huh? G/mole. Down with the gangsters. Okay, we are going to complete the following conversion factors here. Okay? So 1 mole of carbon. If we're trying to figure out the grams of carbon here, you have to look up the atomic mass, which would be 12.01. So this would be 12.01 grams of copper. If you're trying to figure out the atoms in 1 mole, it is always equal to 6.022 times 10 to the 23rd atoms of carbon for 1 mole. Okay, next one's kind of tricky here. If you look at 22.99 grams of sodium, that is the molar mass of sodium, which is Na. So this means that 22.99 grams is equal to 1 mole of sodium, which is also equal to 6.022 times 10 to the 23rd atoms of sodium. Okay. Then we have 6.022 times 10 to the 23rd atoms of barium. Okay. That represents 1 mole of barium. To figure out the amount of grams in 1 mole of barium, you look up the molar mass. Barium is Ba. So this is 137.33 grams of barium. And I can't find my sound effect that I want right now. Let's just go with this one. Okay. That works for me. Okay. Converting mass to moles and vice versa with atomic mass. This goes back to dimensional analysis. Okay? Remember, for dimensional analysis, we had the number up here, right? We had the scribble up here. We had this times this over this equals that. So we're going to have to do dimensional analysis to figure out these problems here. Okay. So if we're doing converting mass to moles here, we are going to use the great conversion factor of 1 mole equals the molar mass of the element in grams. This is from the periodic table. Okay? That is the conversion factor we are going to use. Okay? Okay, if you're one of my students, you've gotten this great, glorious tape, hopefully, where it says 1 mole equals the molar mass in grams, which equals 6.022 times 10 to the 23rd atoms, molecules, and formula units. Okay, we'll go over molecules and formula units later. We'll also go over 22.4 liters of ideal gas later. Okay, so if we're looking at the example problem here, how many moles are there in 28.7 grams of lithium? We are starting off with moles. We're trying to find that. And we're starting off with 28.7 grams of lithium. Right? Okay. We got our conversion factor here. We know that 1 mole is equal to the molar mass in grams. So we look up lithium on the periodic table and it says 6.94. Grams on the top, grams on the bottom. What are we going to go to? Moles. Swish, swish. And then you just solve from there. Multiply and divide, and you have your answer. Okay? Shall I check it, see how this is done? Shall I show you? Okay, here we go. If Rufus has measured out 79.83 grams of potassium in an experiment, how many moles is this? So we have question mark, moles. And we are starting off with 79.83 grams of potassium. Okay. So we got to figure out our conversion factors here. Notice that this is the mole tape here. This always says 1 mole of potassium, which is K, is equal to the molar mass in grams of K. Notice that we have to go to the periodic table here. So instead of mm here, we're going to use the molar mass from the periodic table. Hopefully you can see what I'm doing. 39.10. So this is going to be 39.10 grams. Okay? So this is a one-step problem to get to moles of K. Okay? Grams on the top, grams on the bottom. What are we going to convert to? Moles. You should write the substances as you go. So it's K, because sometimes they change when we get to later on problems. I know. What does the tape say about moles? This is 1. What does the tape say about grams? We're going to use the molar mass. 39.10. Swish, swish, leaving me with moles of K, which is what I'm looking for. And then I do this on my calculator because I do not have the answers in front of me right now. And okay, so you see that this number has 4 significant figures. So my answer should have 4 significant figures. These numbers have infinite significant figures because my conversion factors have all infinite significant figures. So the correct answer for this is 2.042 moles of K. Muy fácil. That was very easy, right?
Hey, listen. Hey, listen.
Yeah. Listen to Mr. Harridan. He knows what he's doing. Okay. Let's look at the next problem. If Bill S. Preston Esquire, those names get me excited, has 1.8 moles of aluminum, how many grams does he have? Okay, so here we are looking for the grams. And we are starting off with 1.8 moles of Al. Okay, so we have to use 1 mole in our conversion factor. And we have to use the molar mass in grams in our conversion factor, so we have to look that up on the periodic table. Aluminum is 26.98 grams of Al. And that is the only step we're going to need. Why am I writing moles? Going to grams. Okay, here we go. Sing the happy song, Mr. Harridan. Moles on the top, moles on the bottom. What are we going to convert to? Grams. How many grams are in my conversion factor? 26.98. You write down 26.98. How many moles are in my conversion factor? 1. Swish, swish. You multiply those numbers. You get an answer. So this is 1.8 times 26.98. Here's the fun part again here. Ready? Significant figures. Yeah, great fun, Mr. Harridan. Significant figures. This number has 2 sig figs. So my answer should have 2 sig figs. So I got an answer of 49 grams of aluminum, because it says 48.5 on the calculator. Okay, part B here. Since 1 mole of an element equals 6.022 times 10 to the 23rd element, we can use dimensional analysis for this too, to convert moles to atoms. We're going to be doing a lot of dimensional analysis this year, okay? So here we go. Here's our example problem. How many moles are there in 1.28 times 10 to the 24th atoms of silicon? So we are looking for the number of moles, okay? We are given 1.28 times 10 to the 24 atoms, okay? We get our conversion factors from our nice little tape. Remember, it's 1 mole equals 6.022 times 10 to the 23rd atoms. I don't need the grams because it doesn't mention the grams, okay? So then we're just going to use that, put our numbers in, swish, swish, and then match up our number of significant figures, okay? Ready for me to do a problem like this? Sure, Mr. Harridan. We are ready. Okay. Okay. Here we go. How many atoms are there in 0.00375 moles of cadmium? We are looking for atoms. In 0.00375 moles of cadmium. Okay, now we look at our tape to get our conversion factors here. Let's see here. What does the tape say about moles? Oh, it's the heart of chemistry. When in doubt, you go to moles and all these problems. 1 mole. What does the problem say about atoms? We're going to use 6.022 times 10 to the 23rd atoms. Okay, so this is a one-step problem here. Okay, moles on the bottom, atoms on the top. Right? What does my conversion factor say about atoms? 6.022 times 10 to the 23rd atoms. And it says 1 mole. And don't forget to go swish, swish, leaving me with atoms. Another thing, it's the E key. You gotta watch out for the E key on this one too, because you gotta do 0.00375 times 6.022 second E 23. Don't forget about the E key. We didn't, Mr. Herdum. Okay, good. And then I got 2.258. Okay, time to mention number of significant figures. Now this one has leading zeros. These leading zeros don't count. So this one has 3 sig figs. So my answer should have 3 sig figs. 2.26 times 10 to the 21st atoms. Okay. Last one we're going to do. Okay, hooray, hooray. Yep. Okay. I know. You want to do more problems. I know. There's more in the regiment to do, so. How many moles of carbon? So we're looking for moles of carbon are present in 4.55 times 10 to the 24th atoms of carbon. Okay, so we look to see what our conversion factor says about atoms. It says 6.022 times 10 to the 23rd atoms. What does our conversion factor say about moles? It says 1 mole. So again, this is going to be a one-step problem here. Atoms on the top, atoms on the bottom. What are we going to convert to? Moles. Swish, swish. How many moles are in my conversion factor? 1. How many atoms are in my conversion factor? 6.022 times 10 to the 23rd. So when I'm doing these mole problems, I'm always using 1. When I'm doing atoms, I'm always using 6.022 times 10 to the 23rd in my conversion factors. And then when I'm doing grams, I'm always using the molar mass, or what we call the atomic mass for elements. Okay? If you don't use the E key on this one, you get the wrong answer. So I'm doing 4.55 second E24 divided by 6.022 second E23. This number has 3 significant figures. So my answer should have 3. 7.56 moles of carbon. Okay? Easily done. Okay. You guys are champions. The legend is out.